Planetesimals are solid objects thought to exist in protoplanetary disks and in debris disks. A widely accepted theory of planet formation, the so-called planetesimal hypotheses, the Chamberlin Moulton planetesimal hypothesis and that of Viktor Safronov, states that planets form out of cosmic dust grains that collide and stick to form larger and larger bodies. When the bodies reach sizes of approximately 1 kilometer, then they can attract each other directly through their mutual gravity, enormously aiding further growth into moon-sized protoplanets. This is how planetesimals are often defined. Bodies that are smaller than planetesimals must rely on Brownian motion or turbulent motions in the gas to cause the collisions that can lead to sticking. Alternatively, planetesimals may form in a very dense layer of dust grains that undergoes a collective gravitational instability in the midplane of a protoplanetary disk. Many planetesimals eventually break apart during violent collisions, as may have happened to 4 Vesta and 90 Antiope, but a few of the largest planetesimals may survive such encounters and continue to grow into protoplanets and later planets. It is generally believed that about 3.8 billion years ago, after a period known as the Late Heavy Bombardment, most of the planetesimals within the Solar System had either been ejected from the Solar System entirely, into distant eccentric orbits such as the Oort cloud, or had collided with larger objects due to the regular gravitational nudges from the giant planets. A few planetesimals may have been captured as moons, such as Phobos and Deimos, and many of the small high-inclination moons of the giant planets. Planetesimals that have survived to the current day are valuable to scientists because they contain information about the formation of the Solar System. Although their exteriors are subjected to intense solar radiation that can alter their chemistry, their interiors contain pristine material essentially untouched since the planetesimal was formed. This makes each planetesimal a time capsule, and their composition can tell us of the conditions in the solar nebula from which our planetary system was formed. Definition of planetesimal: the word planetesimal comes from the mathematical concept infinitesimal and literally means an ultimately small fraction of a planet. While the name is always applied to small bodies during the process of planet formation, some scientists also use the term planetesimal as a general term to refer to many small solar system bodies such as asteroids and comets which are left over from the formation process. A group of the world's leading planet formation experts decided at a conference in 2006 on the following definition of a planetesimal. A planetesimal is a solid object arising during the accumulation of planets whose internal strength is dominated by self-gravity and whose orbital dynamics is not significantly affected by gas drag. This corresponds to objects larger than approximately 1 kilometer in the solar nebula. Bodies large enough not only to keep together by gravitation but to change the path of approaching rocks over distances of several radii start to grow faster. These bodies, larger than 100 kilometers to 1,000 kilometers, are called embryos or protoplanets. In the current solar system, these small bodies are usually also classified by dynamics and composition, and may have subsequently evolved to become comets, Kuiper belt objects or Trojan asteroids, for example. In other words, some planetesimals became other types of body once planetary formation had finished, and may be referred to by either or both names. The above definition is not endorsed by the International Astronomical Union, and other working groups may choose to adopt the same or a different definition. There is also no exact dividing line between a planetesimal and protoplanet. See also: asteroid, dwarf planet, fissile, mesoplanet. Notes and references. Further reading: Discovering the Essential Universe by Neil F. Cummins.